All right, everybody. So we are in week 5. It's testing week. So I thought I would run through a few problems with you so that you can kind of feel hopefully a little more prepared before you start your test this week. So let's get going. Okay, so it's week 5. If you happen to be in the online class for the spring of 2024, this is testing week for you. It's the same thing if you are hanging out in the online version of this class. All right, so this is if we are um, working together live. All right, some testing information. Oof. So yes, we got to talk about this just quickly. You have to use, starting in spring of 2024, you have to use what's called this Respondus Lockdown browser while taking your test in ALEKS. Please take the Respondus Lockdown browser sample test in ALEKS before you take test 1 if you haven't done so yet. You're going to need a photo ID to get started. You are allowed to use a piece of scrap paper, pen and pencil, any calculator you choose, and 1 page of notes. You cannot have your phone, another computer, or another help aid you during the test. You have 2 hours and 30 minutes, so it's a time test. There's 15 questions on test 1. And this is very important too. You can't start the test and walk away. You have to sit down. If once you open the test, you can't close it and return to it later. And then after the deadline for the test has come and gone, you can go into assignments in ALEKS, click on your test 1 score, and review your test submission. Okay, so here's a practice problem. Noelle is at the grand opening celebration of a supermarket. She spins this wheel with 10 equal size slices as shown below. The wheel has 6 black slices, 2 gray slices, and 2 white slices. When the wheel is spun, the arrow stops on a slice at random. If the arrow happens to stop on the border of 2 slices, the wheel is spun again. All right, here's question 1. If the arrow stops on a white slice, then Noelle wins a gift card. Find the odds in favor of Noelle winning a gift card. Okay, so first we need to write down the formula for odds in favor. Okay, odds in favor is always found by M over N or favorable over unfavorable. So the odds in favor, if you take a moment to think about this, pause the video. But if you're back, if you stop on a white slice, that's going to be favorable for Noelle winning the gift card. So that's going to be the number of white slices. The unfavorable is everything else. So that would be the black or the gray slices. Okay, so how many white slices? We have 2. And then we have 1, 2, 3, 4, 5, 6, 7, 8. Unfavorable or black or gray. You can also check yourself by doing 2 plus 8 and getting 10. And that matches what the number of slices are that are on the wheel. Now 2 over 8, as we know, can be reduced. So when you can, reduce. So I think that's going to equal out to 1/4. Okay, if the arrow stops on a white slice, then Noelle wins a gift card. We know that. Find the odds against. So this was the odds in favor. This is odds against. So we're going to write down the formula. Okay, so we know that it's unfavorable over favorable for odds against. Unfavorable is going to be those black or the gray slices. Favorable is going to be those white slices. So it's just the opposite here. So we really have 8 over 2. And 8 over 2, if you divide 8 by 2, you're going to end up getting 4 over 1, or just plain old 4. So the odds in favor of Noelle winning a gift card is 1/4. And remember, you can write it 1/4, or like 1/4 like that. The odds against Noelle winning a gift card are 4/1, or 4/1. All right, hopefully that helps with this type of problem, maybe refreshing you. This might have been a problem you saw maybe in week 1 or week 2. Okay, Kylan owns a business that specializes in helping companies secure their digital data with secure passwords. Orlena owns a business that is at risk of data breaches. Orlena hires Kylan's company to help secure her company data. Kylan tells Orlena to have each employee create a password that has one digit followed by 3 letters. The letter G and the digits 2, 3, 4, and 5 will not be used. This means there's 25 letters and 6 digits that will be used. Assume the letters can be repeated. How many secret passwords can be created using this branded by Kylan's formula? Okay, so we know we're going to make a password that has one digit followed by 3 letters. Okay, and when they talked about the digits, our digits, of course, are 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. They're excluding 2, 3, 4, and 5. So that just leaves 1, 2, 3, 4, 5, 6 digits we can use. So we're going to do 6 times. It looks like they took the letter G out of the alphabet. You know, the alphabet is 26 letters minus G would be 25 letters. So then it's going to be 6 times 25 times 25 times 25. So when they make this 4-digit secret password, they have 6 numbers to choose from, 25 letters, 25 letters, 25 letters. If you multiply all this together, you should get 93,750 secret passwords that can be created. Thank goodness we don't have to go through all of them and figure out all 93,000 of them. Okay, Charles has a box of candies and will randomly choose one piece. The odds against choosing a lemon flavored piece are 9 to 2. So we can even write that like that, or 9 to 2, something like that. What is the probability? Okay, they're giving us the odds, but they want us to convert that into probability. What's the probability of choosing a lemon flavored piece? Okay, so we need to write down a few formulas here. All right, so I wrote down the odds against formula, which is n over n, or no success over success, or unfavorable over favorable. And then I wrote down the formula for kind of probability, and we all know that probability is successes over total outcomes for what you want, favorable out of total outcomes. Okay, so let's break down this 9 to 2. 9 to 2, if it's odds against, this would be unfavorable over favorable, or no success over success. Okay, so if we want to convert into probability, the probability of getting a lemon piece, probability is the success, so we know we have 2 that would be considered a success out of total outcomes. And remember, odds does not care about total outcomes. You have to add the favorable and the unfavorable together to get total outcomes. So you got to do a little quick math there. So 2 over 11 is going to be our probability of choosing lemon flavored piece when we know the odds against are 9 to 2. All right, take a read of this one and then pause the video and come back and see if we match answers. So Tahira is playing a board game. She must roll the die to determine if she gets, this should say, an extra turn. The probability of getting an extra turn is 3 to 17, so that's the probability. All right, probability of getting extra turn. So I'm just going to write down some information here because we're going to pick this thing apart. But they want us to convert this probability to odds in favor. Okay, so I'm going to write my formulas out again. Okay, so we know odds in favor is success over no success. Probability is calculated by success over total outcomes. So they're giving us the probability here. The probability of getting an extra turn is 3 over 17. So that's broken down as successes over total outcomes. But they want us to convert to odds in favor. Well, odds in favor is success over no success. Well, we know success is 3. So that's going to be your numerator. Now we need down below here the no successes, but we only have total outcomes. So what we're going to do is just do some quick math. 17 minus 3 is 14. So that means there's 3 successes and 14 failures, we should say, or unsuccess. So that's gonna go down here. 3/14 is our odds in favor, or 3/14, or 3/14. Odds in favor of Tahira getting an extra turn. Okay, 2 more problems here to practice before we jump into our practice test and Alex. A spinner with 10 equally sized slices has 4 red, 3 yellow, and 3 blue. Mr. Katz spun the dial 20 times and got the following results. Okay, so this is kind of small. I'm going to rewrite this. This is your outcomes. And this is your number of spins. And so we've got red, yellow, blue. So this is red, yellow, blue. And this is 7, 10, and 3. If you add 7 plus 10 is 17 plus 3, you know, that's going to equal 20. And that works because she spun the dial 20 times. So now from her results, this is Mr. Katz's results. Compute the experimental probability of landing on red or blue. So we need the experimental probability. And she ran an experiment. This is the experiment. Okay, the probability of landing on red or blue, we know probability is, you know, favorable or successes over total outcomes. Okay, so we know total outcomes that Mr. Katz could actually land on would be 20. And success, landing on red or blue, well, that's 7 plus 3. That's the red and the blue. So 7 plus 3 is 10 over 20. And the probability then can be further reduced to 1/2. If they're asking for a decimal, just convert that to 0.50. So that is the experimental probability. Now they ask for the theoretical probability. So without looking at this experiment, what do we theorize should happen for us to be able to land on red or blue? Okay, so theoretical means we're going to walk away from what actually happened in the experiment. We're just going to focus on these 10 slices. So we know that if we're working with 10 slices and we have a spinner and there's 1, 2, 3, 4 that are red, we have a 4 out of 10 chance of getting a red, and 1, 2, 3 out of 10 chance of getting a blue. All right, so we want to add these together. So we have 4/10, that's the chance of landing on red, theoretically, plus 3/10, that's the chance of landing on blue, theoretically. Because they have the same denominators, we can add these 2 fractions and get 4 plus 3 is going to be 7/10. But they want us to round to the nearest thousandth place. So 7 divided by 10 is going to be 0.700. We want to go out to the tenths, hundredths, thousandths place. Tenths, hundredths, thousandths place. So when Mr. Katz ran this experiment, she found that getting a red or blue, that happened, you know, 50% of the time, but theoretically it should have happened around 70% of the time. So that's going to help us maybe with this last question. Assuming the spinner is fair, choose the statement below that's true. With a small number of spins, it is surprising when the experimental probability is much less than the theoretical probability. With a small number of spins, it's not surprising when the experimental probability is much less than the theoretical probability. And with a small number of spins, the experimental probability will always be much less than the theoretical. Okay, I hate this word always. That's a turn off with probability. Okay, we don't want to say anything is always going to land on this or that. So that means we're down to A or B. Okay, now we only did a small number of spins. When we ran our experiment, we only did 20 spins. So with a small number of spins, it may not be so surprising that the experimental probability, which was 50%, is much less than the theoretical, which is 70%. Theoretically, the more you spin, let's say Mr. Katz spun this thing 1,000 times. If she were to do that, this 50% of landing on red or blue would get much closer to 70%. So these two will become almost identical when you increase the number of spins. But right now, we're just working with a small number of spins, so it's not surprising these were off a little bit. Okay, a box has 18 candies in it. 3 are caramel, 4 are peppermint, and 11 are butterscotch. Each candy falls into only one of these categories. Juan wants to select 2 candies to eat for dessert. The first candy will be selected at random, and then the second candy will be selected at random from the remaining candies. What's the probability that the first candy selected is caramel and the second candy is peppermint? So the probability that the first is going to be caramel and the second is that it would be peppermint. And you're gonna have to, well, we're gonna have to look at this and say, okay, well, once Juan pulls out a candy and eats the candy, right, then that's gonna be less candies in this box or bag. So the probability of getting caramel is 3 out of 18. And then the probability of getting a peppermint would be 4 peppermints. But instead of 18 candies, remember we took one out, we're gonna end up with 17 candies. So we are gonna multiply these together. 3 over 18 times 4 over 17. It says don't round until you get to the end, round your final answer to 3 decimal places. So if you just multiply straight across, you're gonna end up with a 0.0392 on your calculator. And they want you to come out 3 decimal places. So the 9 looks at the 2 and it says, okay, we're not gonna do anything, we're gonna stay the same. So 0.039, or a 3.9% chance that Juan would select 2 candies and the first one would be a caramel and the second one would be a peppermint. Oh, you probably can't see that. Let's pull that up. Getting sloppy here. Okay, one last problem. I saved the longest, most tedious one for the end. Here we go. All right, Kaylee has a deck of cards, 10 cards, numbered 1 through 10. She's playing a game of chance. The game is this. Kaylee chooses 1 card from the deck at random. She wins an amount of money equal to the value of the card if an even number card is drawn. She loses $5.50 if an odd number card is drawn. We're going to find the expected value of playing the game. What can Kaylee expect in the long run after playing the game many times if she keeps replacing the card in the deck each time? Can she expect to gain, lose, or break even? So we're going to calculate the expected value. All right, let's go for it. All right, I totally recommend making a table. So she's got this deck of cards with the numbers 1 through 10. And then she wins an amount of money equal to the value of the card if you have an even number. So here's our even numbers. So I'm going to put the winnings here. This would be $2. I'm going to put plus sign here. She'd win 4, she'd win 6, she'd win 8, and she'd win 10. Then she's going to lose $5.50 if you get an odd number. So this is minus $5.50. You don't have to make the chart, but I find it helps me stay organized. Okay, and then what's the chances when she pulls out a card from this deck? Well, every single time the probability stays the same, that she has a 1 in 10 chance of pulling out a certain card. So she pulls a 7, that's a 1 out of 10 chance of that happening. If she pulls a 9, it's a 1 out of 10 chance of happening. So these are all the outcomes. This is the money that she would either gain or lose on that particular roll, or excuse me, that particular card, and then the probability. All right, so what we're going to do is we're going to multiply each one of these dollar amounts by the probability. That's what takes the longest. And then once we get done multiplying, we're going to add everything up. So pause the video. Come back and see how you did. See if we can come up with the same answer. All right, so I'm checking back in. I haven't finished the problem yet, but I had to kind of get creative and use 2 pieces of paper. So I started with just negative $5.50 times a tenth, plus 2 times a tenth, plus negative 550 times a tenth plus 4 times a tenth plus negative 550 times a tenth plus 6 times a tenth plus negative 550 times a tenth plus 8 times a tenth plus, this would be negative 550 times a tenth. Let's see if I can cobble this together. It's kind of crazy, and then like a collage here of papers. So definitely make sure to bring scrap paper for your test. Then plus 10 times a tenth. So these, of course, no one likes fractions except for, well, some people do. These, just remember that you're just going to multiply times the top, because really the bottoms, all of these are just ones. So it's negative 550 times 1 over 10. It just becomes negative 5.5 over 10. Okay, same thing here, plus 2 times 1 is 2, and 1 times 10, plus negative 5.5 over 10, plus 4 over 10, plus negative 5 over 5 over 10. So I'm gonna pause the recording and let you finish. You might already be done. All right, so if you've written this out painfully, you should hopefully get something like what I'm looking at here. And then remember, when you're adding fractions, you just keep the same bikini bottom or denominator. Then you're just going to add up all the tops. So you'll just do this in your calculator. So negative 5.5 plus 2 minus 5.5 plus 4 minus 5.5 plus 6 minus 5.5 plus 8 minus 5.5 plus 10, and you're going to end up with, after all that's said and done, $2.50 or 2.5 over 10, which if you take that down and divide it in your calculator, you're going to get a positive 0.25. Okay, all that work for 25 cents. Okay, because you came out in the positive and this was not a negative sign here, this is a good thing for Kaylee. So the expected value of playing this game in the long run is that Kaylee could expect to win roughly a quarter every time Kaylee plays this game. Now, because she's expecting to gain money, right? She is expected to win 0.25 cents. Well, I'm going to write that out here. So she can expect to win, okay? Because this is positive. If this was negative, she'd be losing. And if this came out to be 0 over 10, then it would be actually a fair game, because 0 divided by 10 is 0. So remember, if it's positive, then you're expected to win. If it's negative, there's expected to be a loss. And if it comes out to be 0, it's considered a fair game. Check in Canvas under the announcements. I put a little paragraph that kind of helps you sort that out. So she can expect to win $0.25 dollars, which is not quite $1, it's 25 cents per draw. So this would be a good game for Kaylee to play because she's expected to win. All right, hope this helps you get ready for test number 1.